So these are the parts I just got back from Adam. Came back, same case I put them in when I shipped them to him, and this is my first look at them. By the time I post this, his second video should be out. If you haven't watched that, please watch that first before I open this. There were some complications that he told me about. I'm well aware of that, and you should see that before this here. That being said, let me get this open. So this is my first look at it in person. I have seen photos that he sent me. Some nice cards with his logo. And here's the coupler. And that looks good there. Yes, there is a little bit of, some channels in there, but this is actually the way that it should be done for this. Because, I don't know if he's explained that, but let's get this out here. So that tips out like that. Here, fold that out. Of course, the camera doesn't want to focus. There we go. So the finish looks good. But as I'm sure he has already stated in his video, I haven't seen that video yet, but I know it's coming out. This shaft had a crack in it. Neither of us realized that before I shipped this out. It was not visible at that point. It was just a very hairline fracture. Though actually, when I reviewed my earlier photos, there was a hint of it on this side right by the threads. It was nothing you'd actually notice as a crack, but there was a little mark there. But neither of us saw that it was actually cracked till he put the heat on this to do the flame spray. Nothing that he did wrong. He did exactly as he should have. It's just unfortunate that was there and we didn't spot it. But I can still use this. My plan is I'm going to take measurements of this completely, every factor of it, so that I can, in the future, machine another one. And in the meantime, I'm going to use this. I'll install this. My hope is to get about 2 years out of it, and after that, swap it out, put in whatever I make to replace it. The bushing, obviously, the coupling, there's nothing wrong there. We can use that. I just have to factor that in when I make the new one, that I make the end here just a little bit oversized, so it'll fit this bushing as this one will. So that's pretty much it, and I'm going to get ready to finish everything up on the machine and install this. So please bear with me with the hat and the heavy jacket. It's pretty cold in here. We had -7 degrees last night. And where I'm only in the shop, about once a week right now, it takes a long time to warm this cement up. Usually I'm just using wood for most of the heat in here. Anyways, I want to try and answer some of the questions that I've seen posted about the shaft, about the Cincinnati. So the shaft, I'm going to attempt to use it as a temporary measure. It's definitely weakened. Let's see, how do I put this? The cracks, they don't appear that they're going to run up into the threads or fracture further up. But what's happened is it's kind of run down the side of the shaft. I don't have it here, it's in the house right now. but it's like on the end, it runs across the end and kind of starts to exit on the other side. There's still a little holding it on, but on both ends, when you go past that keyway on the other side, it exits on the outside. I've taken a little time and really looked it over, so it's not going to propagate up into the rest of the shaft. And as a lot of people mentioned, the collar will probably help to hold it together. What I'm concerned about and why I'm going to consider it temporary is because it takes a good section off the side, and the keyway is in there too, is it has made the root of the shaft where it connects to the main part of the shaft is now quite a bit smaller. And I'm estimating at least a 20% loss in the strength of it as far as rotational shear. So that as it rotates, where that damage is, it could literally shear off the end of it. So that's my concern. I don't do a lot of heavy stuff with the overarm. For the overarm, most of it's light. There may be some heavier stuff I want to do in the future, but I'm going to hold off on the heavy stuff until I get the next one made. So that's what the plan is now, is I'm going to install it, I'm going to use it. I'm figuring 2 years, which is about the time when I estimate I'm going to want to do another gear oil change. And during that time, or before I put it in, I'm going to take all the critical measurements off of it. And this is going to be one of my YouTube videos, is I'm going to attempt to machine that part. If I can't do it, I'll outsource it, but I think I can do it here. It's going to be a tedious job, it's going to be a time-consuming job, because the in between the splines on that shaft, there are lands. It goes down and then it goes up and around, and it's actually a curved surface on that, which means I have to do a lot of passes to approximate that roundness in there. It's going to be horizontal work. I'll be doing horizontal milling, similar to the last video I did with the DRO install, because that's how you do those splines, or the most common way to do it, and most practical way for me to do it here. So that's what the plan is with the shaft. The other questions I've been getting a lot is, why did I opt to go with VFD drives instead of a rotary phase converter? And there's a lot of reasons for that. Some may be bigger issues than others. First off, I only have 220 power here, and it's single phase, or split single phase. With the rotary phase controllers, one of the limitations is you have to get one that's big enough for everything in your shop, because you don't want to run multiples of them. And I don't know how much more I'm going to add in here, which is the case for a lot of people that are starting out. So do you invest in a much bigger unit than you're going to use, or do you limit yourself by getting one that's just big enough to run what you have now? The other thing is, when you start up to do whatever you're going to do in the shop, that rotary phase controller is running all the time, and they do draw a good bit of power. You're literally running a motor all the time. They make some noise as well. To me, it just isn't the most efficient way to do it. And I get other advantages from the VFD drives. The VFD drives, you can program them. They do soft start. In fact, it's the preferred way to run them. When you're running a big motor, you pretty much have to soft start it. But that soft starting makes it much easier on the machine. It makes it easier on the gears on the machine. Things like what happened with the shaft, it's a little bit gentler on the startup. So that's one issue that they help with. The other thing is, they have logic in them, and inputs and outputs. You can change the speed of them if I need to. Now granted, the Cincinnati does have a lot of gears, so I can pretty much hit most of what I want just using the gear selection. But if for some reason I need to do a particular speed, particular RPM that is right in between the gears, I can actually set that with a control knob on the VFD drive and get precisely what I want. The other thing is the logic. I mentioned it in one of the videos. I have my table feeds on this are hooked up so that they work with the VFD drive, and the VFD drive can tell how fast the motor is going, whether it's up to speed or not. And I set it up so that if the motor is below about 5% of the RPM that it's supposed to be running at, it will shut the feed off on the table. And this can prevent a crash where you have a motor stall. And this is actually something that happened to Adam, I don't know, about 6 months ago, maybe 8 months. He was using a large slitting saw. He was actually cutting some plate, if I remember. And for some reason, the blade stopped. I think it overloaded, and his motor stalled on his mill. And he ended up bending his arbor that blade was on, because the table kept on trying to go. He shut it off pretty quick, but it still was enough that arbor bent, and I remember him mentioning that. So by doing this where I monitor the speed, if the motor stalls, it just instantly shuts the feed on the table and it can recover. In fact, what will actually happen in a lot of cases is the pause of the table will actually allow the motor to recover. If it doesn't stall completely, it'll stop the table before it stalls and allow the motor to actually pick up speed again, and then it will continue to feed. And if I see it start to go with a jerky motion, I know I have to change my feed rate. So that's the other main reason for it. So how did this all start before I sent the shaft out? Well, it started here. This is the knuckle, goes to the Cincinnati, and I was having a little bit of leakage of gear oil that's in the overarm. But I was in the middle of a job this summer, and all of a sudden it started leaking gear oil really bad. And I figured it was this seal up in here where the shaft goes through. So I started disassembling this, and turned out, well, the seals were bad, but it turned out this gear had come loose in here. And this may be related to what happened to the shaft. But this was all loose. The alignment pin in here was actually sheared off. I've taken care of all that. That's all fixed already. But this got me into where that coupling goes, because, well, actually, and this is the one that connects to it. Now this one I use as a spline, but that goes on there, and you've got the block in here. It's sort of like a Lovejoy, and the other part that you saw Adam work on is the mating part to that. And that shaft will come out here and goes into the gearbox in the machine. So I think they hit something. You know, there's another, the actual quill head goes out here. There's two bevels on, or angles here. So I think that's what happened. That's how this got started, was I was trying to fix that. You know, and obviously when I took it apart, I could tell it was all loose, and I knew something was wrong. And I saw the galling on there, and that's when I decided to send it to Adam. Because I don't have the experience with flame welding yet. So there are some other repairs that I'm also doing while working on this machine, and I've mentioned this in some of my prior videos. There are these T-nuts that hold this together. We'll go through here and hold it onto the overarm, and there's another set that hold the spindle assembly. The quill goes on here. They sit in here like that. Well, these were stripped out. It was on, but the former owner had put a second set of nuts on there trying to hold it together because the threads were stripped right out. So I am in the process now of making some new ones. I had tried contacting Cincinnati about just buying new replacements for them. The price they wanted, I could just about buy a whole nother machine, so that's not going to happen. So in making these, I've used bolts that I bought that were quite a bit larger, and I've turned them down, making replacements. And there's going to be video on this. So that is, my plans here now are, for the next month or so, I'm going to be working on getting this together. I've got a lot that I've already done, and I'm going to be putting up videos periodically about the process of doing that. And I'll continue to film as I reassemble everything. You know, people have asked me about, filming, putting the shaft back in and trying it out. That will come. We're definitely getting there. The other issue I've got to mention that I had with the mill, and this is going to be on those repair series. I'm going to be starting that right off. It's the next ones I'm putting up. So I also had a loss of hydraulic pressure in here. I was still able to use it, but it was not at the specifications it was supposed to be, and I knew something wasn't right. And I had looked at it once before. I checked the pump was good, and I came to the conclusion that there was an internal leak inside the knee and the hydraulics. So that was part of the repair, going to be part of the repair series. That I've already fixed all that. It's all working right now. But it was quite a bit of a process to find the leak, diagnose it, and get that repaired. But now it's taken care of. So the last question that I got a lot of, why 3 inverters in the motors? So there are 3 motors in this. How they're arranged is there is one for the horizontal spindle, there is one for the overarm. They run independently. You can actually run them both at the same time, which I've had people ask me about. I don't see that that's practical to do, but it can technically be done. They will run at the same time. So the third motor, which is down here, that one runs the hydraulic system, and it also runs the table, or the feeds and speeds, including raising the knee. There are physical gears in there. The hydraulic system, what it does is it operates clutches that engage and disengage for the table, and also on the horizontal spindle that has a clutch on it that engages and disengages. Now wait a minute, let me get that right. The horizontal, there is a clutch on this, but the clutch is a manual clutch which works off of the lever on the side that are used to engage and disengage. The hydraulics on the horizontal are actually, the gears are hydraulically selected. When you turn the speed selector for the horizontal, it's actually opening and closing valves inside the body in here, and that selects the gear. The knee is different. That is more like a standard transmission where you turn the dial and it actually physically meshes the gears. The clutch on that is hydraulically operated though, and works with an electric solenoid that engages and disengages it. Your feeds on the table are built right in. It's not like a Bridgeport where you have an external feed on it. It's all built right into the knee, which is one of the things I really like about this. It's quiet, it's smooth, it's strong, and it's reliable. So I think I've covered everything for now, and the next video I post is going to be the start of taking things apart here and going through the repair process. And that will probably be a series for a while. I'm also going to be doing a few other videos in between. I've got a trailer build that I did, more of a fabrication project, and there'll be other stuff thrown in as well. So thanks for watching, and I'll be back soon.